Suppose that A is an n by n matrix and that the equation matrix A times vector x equals vector B has a solution for every vector B in Rn. And we're asked to explain why A must be invertible. So we suppose A is an n by n matrix. And we also want to suppose that for every vector B in Rn, the equation matrix A times vector B, matrix A times vector x equals vector B has a solution. So we recognize this statement. Suppose that for every vector B in Rn, matrix A times vector x equals vector B has a solution. We know that by the equivalence theorem that we saw in section 1.4, that this is the same thing as saying that every row has a pivot. And we know that since matrix A here is an n by n matrix, a square matrix, then there exists n pivots. We can take this one step further again, since A is an n by n matrix with n pivots. These n pivots must exist along the main diagonal. Which we recognize as the n by n identity matrix. So therefore, matrix A is row equivalent to the n by n identity, and thus A is invertible.